Hello YouTubers and fellow hams, 3D printing enthusiasts. Well, way back when I did my first video series on 3D printing for ham radio, and I did a video on design, I introduced you to a design program called TinkerCAD. And it's a very, very simple, on the surface, simple program, but still powerful enough to do quite a few interesting things and complicated things. Later on I did a video on Onshape, which is a far more powerful 3D design program, a little more complicated, a different approach, but still easy enough that it's fairly easy to learn. And I demoed designing a simple knob for a J38 style key. Now I had a comment on that particular video that caught my eye. Let's pull it up here. Okay, here we go. N1XF. You didn't say your name, so I should have looked it up, but I didn't. Sorry, my mistake. He commented here, let's see what Kevin is going to have me learn next. I could have used this earlier. I'm printing up a guy ring for my jack-type pole. It has 3 ears 120 degrees apart. Something that was guess and place in TinkerCAD. Well, yeah, guess and place, not really. There is a way to actually precisely place those things 120 degrees apart in TinkerCAD. There's a lot of different things you can do in TinkerCAD that you can do in a roundabout way, utilizing simpler tools to provide more complicated tasks. And your comment made me think about that, and I thought perhaps I'll do a little tips and tricks video on TinkerCAD, and maybe a couple of things in Onshape. Things that I've discovered, and there might even be better ways to do what I'm going to do, but these are simple tricks for me that work just fine, and they show you how you can get a lot more flexibility out of something like TinkerCAD by breaking tasks down into smaller steps. So let's get into TinkerCAD, and what he was talking about was a guy wire collar. Now, his design was probably different from this, but this is a really basic idea. A collar for the guy wires is something that would go on your mast, right? The mast would fit in this middle part here, and then you'd have these holes where you could hook your guy wires up to straighten the mast and stabilize it. So a real simple way of looking at this is like a big washer with 3 equidistant holes here that are exactly 120 degrees apart from each other. Okay, so that's what we're going to design real quick in TinkerCAD. And when I say quick, I mean, yeah, quick, because it's really going to be simple to do. So let's go into TinkerCAD. Now here you can see I've already built the part with the 3 holes that are 120 degrees apart. And I'm going to show you exactly how I did this, all right, step by step. And you're probably going to do a facepalm when you realize how simple this is and the trick that I'm using to do this. All right, so let's zoom into a clear space here. Now I went out and I measured a piece of mast pipe that I had, and I found that this center hole, or the outer diameter of the pipe, was 35 millimeters. And I wanted about 20 millimeters of flange sticking out, which would give me room to put the holes in and still enough strength. So let's start by building the flange. All right, so we're going to start with a cylinder, and I'm going to make its diameter the outer diameter of the flange. Okay, so the pipe was 35 millimeters. I'm adding 20 out here to the side, right? So if we're looking at diameter, then I have to take this 20 plus that 20, so that's 40, plus 35 will give me 75, right? 40, 56, yeah, 75. Just double checking my math in my head. So we'll make this 75 millimeters. Oops. 75 millimeters. Okay. And I'm going to just squat this down to say, let's say 5 millimeters thickness. Okay. So that's the outer diameter of our flange. Now we're going to put the mast hole in the middle, right? So I'm going to bring in a hole. And we're going to make that hole 35 for our mast. Well, I'd actually want to make it 35.4 because 3D printing, you're going to have that little bit of overlap from the bead of plastic that's extruding. So we'll make that 35.4. Okay. And then I'm going to center this hole in my flange. So I'll select both together with Shift. Got them both selected. I'll hit the Align tool up here in the upper right. And I want to align the hole with the flange. I don't want to move the flange. So I'm going to click on the flange's body and then use this center hole and that center dot there. And now our hole is aligned in the center. And I can group them together. And there is our flange. Oh, you can see these facets in here. I probably should have increased the... Let me just make that change here. We'll take our hole, increase its sides to 64 so it's smoother. There. Now I'll group them together again. Okay, so here's our flange. Now, we need to put our three holes 120 degrees apart. Let me bring in a hole, and let's just make our hole, let's say 8 millimeters. Okay, so there's my hole. Now, what the gentleman commented was that he had to guess in place. So what he probably did is he probably put one there, Control D to duplicate it, and just guessed like there, Control D to duplicate it. Oops. And like there. Okay, and you can visually guess and get pretty close. But if you're not exactly right, you're going to have unequal tension. I don't know. You could probably get close enough and it would be fine for this task, but let's say you really want to be precise. You want to have those exactly 120 degrees apart, right? So let me get rid of these two. So we start with our first hole. I want to center that. I want it to be exactly in the center of this. This is a 20 millimeter flange, right? So I want it to be exactly in the center. I'm going to make a measuring stick. What I'm going to do is I'm going to bring in a box. All right? And I'm going to make that box long and thin and short. And the length is what's important here. Okay, what I want is I want the ends of this box to end short of the outer part of this flange, about as far in as I want the holes to be. Okay, so my hole is 8 millimeters, right, in diameter, and my flange is 75 millimeters in diameter. Now, if I want the edge of that hole to be 10 millimeters in, let's just imagine that we're going to put holes on opposite sides. I would take 75 minus 20, and I would get 55. No, wait. 75, 65, 55. All right. That is going to put the edges of this box on the halfway point, where the center of this hole would have to be. But the hole, I want the outer edge to be 10 millimeters from the outside, so I need to make this a little bit shorter. So 8, half of that's 4. 4 and 4 is 8, so I'll make this 8 millimeters shorter. Is that right? Well, let's see how it looks. So that would be 47. No, 46. That seems too short. All right, let's center this on there and see what we get. Select those two together, align. I'm going to click on the flange and center it here and here. No, that's too short. That's 10 millimeters too short. I made a mistake in my math somewhere. Make that 56. Center that on there. Okay, that looks better. Yeah. Okay. So now I've got this measuring stick, right? I'm going to use it to align my hole. I've centered this on my flange. I'm going to select it, and I'm going to select the hole together with Shift, right? I'm going to use the Align tool. Now I don't want to move my stick. I want to move the hole. So I'm going to click on the stick once, and that will shift my alignment dots over to the stick. And I'm going to click this one to center it this way, and I'm going to click this one to center it up on the end of the stick. So now, there is my first hole. Now, if I want to place another hole 120 degrees this way, here's where we get tricky. Okay? I'm going to select that hole, and I'm going to Control D to duplicate it. Now, the duplicate is exactly on top of the original, so you can't see that there's two of them there, but there is two, and only one of them is selected. So I'm going to hold down Shift now, and I'm going to select my measuring stick. So I've got my measuring stick and that duplicate hole selected, right? I'm going to group them together, and then I'm going to take this rotation tool here for the stick, and I'm going to rotate it 120 degrees. Okay, and then I'm going to ungroup them. Boom. I've now placed my second hole 120 degrees around from the first one. Now I'm going to do the same thing. I'm going to select the hole, I'm going to duplicate it, Shift and select my measuring stick, group them together, and then grab the little rotational tool and rotate it 120 degrees again, right there, and then ungroup them. Now I can get rid of my measuring stick. Don't need it anymore. Its job is done. I'm going to draw a box to select all of those and group them together, and I have my flange with my three holes 120 degrees apart. So that is the trick in TinkerCAD to rotating something precisely like that in this particular case. I made a measuring stick by just dragging in another object and setting it to the dimensions that I needed, and then using it as a reference to lining things up. Now you could do the same thing if you wanted to put a hole, if you had a square part, and you wanted to put a hole so far in, you could make another piece of geometry that's exactly that distance, drop it there, and then line the hole up with it, and then get rid of that piece of geometry. You could use another part as a measuring stick. So that's how you do it in TinkerCAD. Pretty easy, and we've created our part. I still had my length wrong on my measuring stick. Those holes are too far in, but you get the idea. Actually, that'd probably be fine because you want the strength out here. But anyway, that's how you do it in TinkerCAD. So real simple little trick there. Now let's go into Onshape, and let's create the same collar in Onshape, okay? So I'm going to take the top-down plane here as the plane I'm going to draw my sketch on for my initial sketch. And I'm going to create a new sketch, and we'll call it flange. And I'm going to simply draw a centered circle here. Put the pointer over that center point. It lights up with a square around it, meaning that's where it's going to lock the center of my circle. Drag out a circle, and we'll set its dimension at 75 millimeters. We're in inches. Onshape defaults to inches. Let me change that to millimeters so I don't get confused. Yeah, I know, I'm in the US, I should be using inches. Well, the rest of the world has switched to the metric system. We're one of 4 countries that are holding out in the old system. We need to catch up. I'll probably get a thumbs down for that, but you know, reality is reality. We're going to have to catch up with the rest of the world and start using the metric system. Anyway, okay, so I've created the outer ring of my flange. I'm going to extrude it. And we'll make it, what did I use, 5 millimeters before? We'll make it 5 millimeters thick. What? Why didn't it? Oh. There. Okay, so there's our outer part of our flange. Let's do the hole for the mast. So I'll select that surface. I'll do a new sketch. We'll call it center hole. And I'll draw my circle, and that was going to be 35.4 millimeters. Alright. And we'll take that center hole, and we'll extrude, remove to make our cut. And through all. Check. Okay, so there's our basic flange. Now we need to do our holes. So I'm going to select this top surface. sketch. We'll call this guy holes. And we'll put our first hole up here. All right, now Onshape has lots of nice tools for doing things really precisely. So I've got the top of my flange here. I've got this center line that is, you know, lined up with the center point. So that's where I'm going to start my hole for the circle for the hole, right? And so it's already centered on there. I'll make that 8 millimeters. And I wanted this to be 10 millimeters in from the edge, right? So we'll pick our dimension tool. And I'm going to dimension from the outer part of this circle to the outer part of that circle. And we'll make that 10. It's going to look like the other one looked. Maybe I'll shorten that just for, we'll just leave it there. Okay, now I've made that circle for my first hole, but I need to make 2 more 120 degrees apart, right? Now this is where Onshape gives us a lot of power. This up here is a pattern tool, right? I want to do a circular pattern on this part. Now it has already guessed, and guessed right. See, it says 3 times, and look at this. There's one here and there's one here. They're already 120 millimeters apart. It's going to intelligently speculate based on your geometry what you're wanting to do here. And as long as I want to do 3, it's going to place them equidistant around the center point. So you can see it's already got one there, it's already got one there. It's just waiting for me to click the left mouse button to confirm it. I'll click, and there's my 3 holes. Just that easy. So now I'll come up here to guy holes, I'll do an extrusion. We're going to remove through all, and boom. We've got our flange with our 3 holes. Just that easy. Onshape is way more powerful and easy to use. What do I want to do here? I wanted to turn that to a perspective view. There we go. That looks better. Yeah. So there's our flange. Just that quick. And we could do other things in here that might make it a little more functional. You know, if you were going to use guy ropes through these holes, those harsh edges of the holes could damage the rope. So I could come on here and I could do a fillet. And I could pick that one, and 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 we'll make that 2. Why doesn't it like that?
Whiskey 9 Tango Echo repeater. The time is
I guess we can't do. No, that's right. We can do that. Why can't we do that? Alright, we put a nice fillet on those. We can put a fillet back on this one. There. Okay. So we can put these nice little fillets in here to round those out so that they're not going to damage the rope. In fact, we could do the same thing on the outer part of the collar here. Fillet. That. And that. And there we go. So that's a little bit cleaner looking, as you can see. It's going to be easier on the ropes. So there's some advantages to Onshape. These fillets would be really hard to do on TinkerCAD. The other advantage here is if I decided that these holes were too close to the center and I wanted to move them out, it's a super easy thing to do in Onshape. I just go up to my sketch for the guy holes and I double click it to go back into the sketch mode, and you can see all our dimensions are still here, and this is 10 millimeters. What if I want that to be a little closer to the outside? I'll just change that to 8. All the holes move out. I'm done. I've made my change. Now that's much cleaner. So you can very quickly update things like that in Onshape, and all of the rest of your steps, the fillets and the duplicate holes and everything, get updated right along with it. So there you go. That's how you could produce that collar in both TinkerCAD and Onshape. So you can do it really precisely in TinkerCAD using that little trick of a little extra geometry temporarily used as a measuring stick. But as you could see in Onshape, far easier to manipulate and accomplish and produce a much more refined part. So I hope that that helped the gentleman who commented, and anybody else that might be exploring these design tools for 3D design. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.